So Dielectric radio business is worldwide. We've got a lot of investment into R&D and a lot of product that goes globally. So anything that you're listening to over the air, you're probably listening to on a dielectric antenna and combiner system or filter system. So we build everything from post transmitter all the way up to the antenna for the FM market. So we've been around since 1942 and been doing FM for a good portion of that. We started doing FM under RCA and supporting their needs, and then eventually picked up the RCA product line. In the late 1990s, we also picked up the Harris product portfolio, which included a lot of FM products. So we've got a good mix of engineers in different ways of doing things that we've blended together over the years, taking the best of a lot of our history to produce state-of-the-art FM economical systems for our end users. We have just recently deployed a system to Australia, an antenna system. It was a 10-bay half-wave spaced array broadband ring style for an auxiliary system, which had a very successful installation, and we were able to grow upon that and are quoting multiple systems in Australia as we speak on the FM side.
You're very active in the Asia Pacific region as well. Tell me about the countries that you service and what kind of transmission you have across Asia Pacific.
Sure, absolutely. So we just talked about Australia a little bit. So we're active in Australia. We have a distribution partner called 90 Degrees North. They have an office in the Philippines where they stock some of our FM components. They're quick to deploy. DCRTs, which is our lower end, most economical ring style that we have. He stocks a lot of those in the Philippines and distributes those throughout the country. So we've had a ton of success in the Philippines, and through that distribution channel, we're starting to talk about getting additional countries covered. So we're trying to grow that partnership to see a lot more distribution within Asia Pacific.
Well, having a base there in the Philippines, you can easily service and expand into Asia proper, India from the Philippines, China.
Yes, absolutely. So throughout the whole region, and as you said, him having a stockpile of emergency equipment, being able to get up on the air quickly, really suits the Asia Pacific area nicely. So we're able to. He's able to stock and inventory some of those components, get them out there real quick as we continue to look at other areas in higher power systems that might be their final system for the entire region.
That's really important in some parts of Asia Pacific because of typhoons and cyclones and damage to existing infrastructure. To be able to have a supplier that's got some backups and can get it quickly is really important to broadcasters.
Yeah, absolutely, 100%. Couldn't agree more. The key there is, as you said, it could be natural disasters that gets them right back up on the air. It could be they're trying to fulfill and get on the air quickly and fulfill a license need at a later date, but at least they're broadcasting and getting their signal out, getting their story out. So having that flexibility and being very nimble and getting the customers on the air as quickly as possible in from the region versus coming from the United States, sitting on a boat for up to 12 weeks certainly is an advantage and something that broadcasters demand right in that area. So we're able to fulfill that need, get them up on the air, and then continue to work with them on future license requirements or as typhoons hit or natural disasters, and make sure that they're able to get emergency alerting system out and or just what they their radio station signal out.
What new products are you showing here at NAB?
And we have so much to talk about on that front. We are focused on the FM market, a lot of innovation that's coming from the engineering team back home. if we start with the combiners first, we've got a new CIF combiner, which is a constant impedance filter that you can use to add multiple stations to. So it would be a broadband system like we talked about. The Australia system is a 10 bay half wave broadband system with multiple signals going in. It's got leading industry low losses, so it's very efficient. The other thing that we've spent a lot of time and are showcasing and also deploying currently is our Manifold combiner. So we've spent a lot of time in simulations. Again, that's to combine multiple frequencies into one antenna. Instead, it uses a little more than half the parts than a constant impedance filtering system. So it's a lot more economical for the end user to be able to put broadband systems into play. We've enhanced that portfolio to be able to add stations at a later date and/or take stations out that might be having issues and allow all the other stations to come into play. So one of the things that we're working on as we speak is a 13-channel manifold combiner. And one of the key things when we're looking at that, it's the smallest combiner that's ever been made footprint-wise. So that combiner would easily fit this room that we're in today. So it's easy to deploy, and customers like the smaller footprint because you're going into transmitter buildings across the globe that some may have the space, others won't. But we've solved a lot of problems with this new design, so we're very excited about that. We've got a lot to talk about on the antenna side as well. We came up with what we're calling is a ringmaster antenna. That antenna system is patent pending. It uses variable bay spacing, so it may use multiple bay spacings in the array to maximize an economical solution for the end user. So typically where you're using 16 bays, this new technology allows you to use 12. So it's a lot more reliable, less wind load on the tower. There's so many advantages to the customer. And with this technology, cost of ownership goes way down, gives you the same thing that traditional other manufacturers would give. So pretty excited about that technology. Moving on from that, we're working on a new panel as well. Typically, if you look at a master panel antenna, it comes with 2 inputs. So what we challenged the engineering team with is let's come up with a broadband device with a single input. So again, what we're doing is we're removing half the feed system of the traditional panel system, which is a lot more economical for the end users. And the VSWR performance and the electrical specs are either on par with what's out there in the industry or vastly better. So it's all about the cost of ownership from the end user, coming up with economical solutions, making it more reliable with having less connections. So pretty excited about that product. And there's a few other things on the antenna sides that we're working on as well. So there's a lot of activity at Dielectric on the innovation side. And one of the other things that we've been working on for a long time is we do all of our simulation now in a software package called HFSS, which is high frequency simulation software. It's as accurate or better than the traditional methods of R&D, which was let's make some parts, tweak, go to the machine shop, and it was an iterative process. It's all done virtually. And one of the things that Dielectric does better than anybody else in the industry is we're able to solve that in the software package and do those iterations behind the scenes, and the computer's doing the work. So our time to market on R&D is a lot quicker, and the things that we're able to do versus what we were able to do even 20 years ago is vastly improved.
And that must be good for the customer too, because you don't have to recover all that time and expertise hour by hour in research and development and tweaking and trying things out.
Yeah, absolutely. I think it's a win-win for everybody involved. And the end users see that we're quick to market. We're able to quickly determine, hey, what you're trying to do at these sites. Let us bring that into our R&D department and see if it's valid or not. And if it is, then we can continue to solve problems And again, it's so quick. We're able to expand and continue to be the leading edge of technology on the radio side.
How many staff are there and what kinds of people are there?
So our engineering department in general is probably almost 24, and we have everything from electrical engineers that are doing a lot of the simulation that we just talked about, mechanical engineers to make sure that, specifically on the stuff that goes on the towers is strong enough to withstand the winds and rains and storms. And then we have a design team that models all this stuff in 3D software. So again, yeah, pretty nimble, diverse skills. We're able to analyze heat and electrical design, and again, it's all done in the software package. So it's a skill set that we say is second to none within the industry.
As the weather changes, climate changes, there seems to be more extreme weather. In your software packages, are you allowing for huge wind gusts and things like that?
Yep, that's an excellent question. There's codes that we have to build to, and those codes are becoming more and more stringent based on some of these weather changes, and then we're analyzing that to make sure that whatever the wind speed is and some of that criteria, the ice loading might be different than what it was depending on some of the weather patterns and changes. So all of that gets analyzed and verified. So the mounting structure, the antennas have to withstand all of that. So I think that's one of the things that we do very well in probably industry leading as well, that those types of codes are met and the customers know they have peace of mind. The storm's coming, but we're going to be able to operate and stay on the air because the specifications that needed to be met were met by Dielectric.
Sustainability and power usage, of course, is one future need that everyone's talking about.
Yeah, so I think it goes back to some of the stuff that we're doing on the antenna side, where we're getting the same gains with a lot less parts, right? So, a lot more sustainable, less things to fail on the towers, and those types of things that we're working on that are solving real world problems today. We're changing as the needs are changing within the globe, and staying relevant as we go forward.